Okay. Hello, everyone, and welcome to our National Disaster Preparedness Training Center's third Thursday virtual event. Today, our topic is impacts of space weather on Earth's atmosphere. And Lieutenant Colonel Todd Bloom, who was shown on our flyer, has asked Mr. Sean Dahl to lead us with his presentation. Sean is the Senior Space Weather Forecaster with the National Weather Service, also known as NOAA. And we also lastly ask that you please enter your questions in the chat. Thank you so much for joining us. And Sean, I'll let you take it away.
All right, thank you so much. Hello, everyone. I'm glad to be here and take part in this and let you know a little bit more about space, whether or not what that means for emergency management communities, whether you're in Hawaii or anywhere around the world for that matter, but especially with note to our country. So this is our Space Weather Forecast Office. You see through these two giant windows here. SWPC itself is comprised of about 70-something personnel. Half of that is augmented, kind of, if you will. They're called series employees from Colorado University, and then us federal employees here as well. So we are part of the National Weather Service, and we're very proud to be part of that mission because one of its key aspects is protection of lives and property, as you all know. And believe it or not, when it comes to space weather, we are protecting. Are you guys seeing a little engine thing come up on the screen? Like a...
Yes.
Yeah. I'm going to have to keep clicking that off every once in a while. We're in the process of a whole bunch of little updates, unfortunately. Anyway, so that's one of our primary missions, is the protection of lives and property as well. So space weather is going to impact our technology. Not really anybody's lives, unless you happen to be an astronaut or aviation. Then there are some instances where it could have a health risk to an individual. But for the most part, we're talking about our infrastructure in the form of technology that we rely upon today. So what exactly is space weather? Well, it's what's taking place on that giant ball of burning gas 93 million miles away, at and between the sun and the earth, and ultimately at here and around our wonderful planet. So the way I like to look at it is our warning area of responsibility is big. Now, the federal government is very proactive right now, regardless of the administration, even during the former presidency on through this one. Whatever happens next, I would assume there would be no changes here to any space weather actions that have been taken, because the government understands the impact that space weather, a catastrophic type space weather event, could have on our infrastructure in the form of satellites that we rely upon, or the power grid that we rely upon, communications, whether it's satellite comm or radio comm, GPS accuracy. All these things can be impacted by space weather. So these actions, examples you see here, continue to take place. Bill Murtaugh, our program coordinator here at SWPC, he's on his way back to Washington, D.C. in 2 weeks to do more speaking to political officials about space weather. Why does the government care? The litany of impacts that space weather can be responsible for causing, and look at the monetary amounts on the bottom. In some of the more catastrophic scenarios, and unlikely as they might be, they are possible. That's why the government's investing into this business and making sure we're adequately prepared for any such calamitous space weather event. But yeah, we're talking billions of dollars here. And usually that revolves around the loss of power. If there's a massive power outage in a section of North America here, in particular the United States, or even elsewhere around the world, that affects commerce, that affects shipping delays, causes port issues. Hawaii relies very much on shipping coming in with supplies. This would just delay things because of all the aspects of power that go into that. And that's just one example. So you see that right there on the bottom about the supply chain. So we really add up. And then just domestic losses alone in dollars, over $40 billion is estimated in some of the worst case scenarios. So a little closer look at our forecast office there. That's what it still looks like to this day, even though this picture was taken a while ago. But note the key partnerships that we have here. The United States Air Force is absolutely essential as a shared business in this. They have their own Space Weather Operations Center in Nebraska, and we coordinate with them several times a day, more often than that when needed. We're talking about some serious space weather. See FEMA on here. NERC is the North American Energy Reliability Corporation. A lot to take in there, so we'll just say NERC. That's basically the power grid of North America. We'll talk about that more later on and what that means as well. And of course, because we're a forecast office, an operational critical system here for our country, we are staffed 24 hours, 7 days a week. So we all get the luxury of working rotating shifts, just like any weather forecast office. So what is it about the sun that makes it unique and cause space weather storms and events? Well, it's really about the solar cycle. There's aspects and dynamics of the sun that lead it to behave in a certain way cyclically, where almost every 11 years we get a peak of solar activity. And in between, there's not much happening. So here on this example from the previous solar cycle and solar cycle 24, these images from NASA kind of show you how it progressed year by year. This is looking at a certain wavelength of light that's not the normal sun that you see, but you can see some brighter active regions showing up. And then I put some sunspots in there for 2015, which is kind of the peak of the activity from the last cycle, 2014 to 2015. Now look at the size of the sunspot groups compared to planet Earth. About 109 Earths can fit across the center of the sun along its equator. So these sunspot groups can start to get massive around solar maximum at times. And it's these sunspot groups that we really care about because their underlying cause is a strong area of localized magnetism which pops up on the surface of the sun. And when it's intense enough, it reveals itself as sunspots. So one of our first clues as forecasters is looking for these areas of magnetism, seeing how sunspot groups developed, and then classifying and analyzing to see and try to predict the chances of a space weather storm. So what's going on currently? Well, we're in solar cycle 25, and we are approaching peak activity. And I'll talk about more of that towards the end of this as well. What is it we're looking at as forecasters in space weather here? Well, many things, but the big three are these right here. Something called solar radiation storms, HF radio blackouts, and geomagnetic storms. That's the impact. So the forecast we're trying to do here is impact-based because this is what serves people. They want to know what that means to them and their technology. The underlying cause that we're trying to forecast is what you see in italics on the right. So solar proton events, solar flares, and coronal holes and coronal mass ejections. I won't talk to coronal holes today because those usually don't get to be severe and extreme levels, but coronal mass ejections most certainly can. Notice the NOAA Space Weather Scale on the bottom. That's what these three things equate to. Now, just keep in mind there's levels of activity below the level it takes to call it, say, a G1 or an R1 or S1 storm that we may be warning about and taking action on. But when we get to a certain level, that's when it meets the NOAA Space Weather Scale. So now we're talking about things a little more notable. So minor all the way up through the extreme levels. So a solar flare, that is a blast of energy that happens on the sun, often very impulsive, meaning it can happen very quickly, minutes, and be done. Sometimes they're long duration and they can go up and they can take a long time to come back down. This happened in 2017 and it was notable for a very good reason. I'll share that with you here in another 2 slides or so. But this is just one of the most recent ones. We had an R3 level flare, so that was strong right in the middle of the scale on New Year's Eve day, December 31st. And that flare was quite notable in how strong it was so far in the solar cycle. And the reason these are important is when they happen, the sunlit side of our planet, the atmosphere above us, is immediately impacted by these flares and changes in such a way that high frequency radio that airlines rely upon as a backup system, ham radio operators utilize, and I know in the state of Hawaii and elsewhere, especially on islands, ham radio is very important when it comes to catastrophic weather events. That's how things get, information gets relayed. That's how storm reports happen when everything else is down. So yeah, very critical that this element could not be workable during these events. This is what a solar flare looks like. That's the same flare from December 31st on our imagery that we use from the GOES satellite. You can see that I got so intense that it kind of started causing some weird artifacts in the imagery. That was just a 3, just the middle of our scale here with that particular flare. The other thing to keep in mind is it doesn't matter where flares happen on the sun. As long as they're anywhere where Earth can see it, as you saw, that was on the limb or maybe even just beyond the limb when that happened, it heated up our atmosphere. It caused those changes to happen that caused some HF radio issues on that particular day. Other events, it does matter where they happen on the sun. So here's this example I was talking about. In 2017, when hurricanes had ravaged the Caribbean islands in the Atlantic, Puerto Rico was without power, other islands very devastated. We happened to have the largest solar flare that we had the previous solar cycle. That one reached just below the R4 threshold. So it was still an R3, but it was at the very high end. So islands had no power because of the hurricanes. Telephone lines were ripped apart. Cell phone towers were inoperable. SATCOM wasn't fully available to everybody. So how were they trying to communicate with the mainland here and on the continent? HF radio, ham radio. They couldn't even do it. Hurricane watch networks that were reporting vital observations to the National Hurricane Center couldn't do it because that's how they do it. Ham radio reports. So when you combine a massive terrestrial weather event with a catastrophic, or not a catastrophic, with a major space weather event, that really impacts lives even more so. So imagine hurricanes rolling into Hawaii and you happen to have a space weather event going on at the same time. That's when impacts are going to compound potentially. And this particular flare was not impulsive. It went up and then it stayed up and was very slow come back down. So the impact to HF radio actually lasted a few hours in this case. Something that's very unique, and believe it or not, this is the only way we can get this information is from the United States Air Force, thanks to their observatory network, which includes radio telescopes like the one you see in the bottom right. On December 14th, we had what had been the previous strongest solar flare of the cycle. And you can see it circled in yellow on the sun there where that was. And that's the sunspot group that was associated with that flare. This impacted aviation, but not for the reason we normally think about, which is HF radio, that 3 to 30 megahertz band only. This one went way above and beyond that. It affected bands all the way up into the super high frequencies. Now, aviation here in the domestic United States relies and does a lot of line of sight communication. So they use frequencies above HF, very high frequency called VHF and UHF bands. They were having a miserable time communicating with air traffic control because of this particular event. Because not only did we have the HF radio issue from the flare, this produced one of those massive radio burst signatures on frequencies that the airlines were normally using, and a normal solar flare would not bother them. And in this case, it did. And this was felt all the way across the country of the United States. And you can see where the sunlit side of Earth was at the time. And you may be thinking, well, that was really over South America and only the southern US. The reason this was an impact is because you really have to be looking towards the sun. So winter, the sun is lower in the sky. Airplanes talking to air traffic control or vice versa. Many times those signals were looking in the low horizon towards the sun. So this was felt all the way up into Minnesota, the Dakotas, all the way out over to Washington State in particular, a lot of those places. So very dramatic. And I bring this up with a little more detail like that because a lot of urban environments, I don't know if Honolulu does this, but a lot of cities in the mainland do, they have repeater systems to get around the buildings and things so they can use their line of sight frequencies. Are there times where this could be perhaps an impact because of that? Even if it's just minutes, which these usually are? Yeah, it most certainly could be an impact. So once again, more stuff. Now we can't forecast a radio burst event. We don't even try, but we do focus on the flares. Solar radiation storms. There's a frightening sounding one, right? Well, we've been in a solar radiation storm since Friday of last week. I think it just finally ended. You probably didn't hear much about it. Why? Because we're fully protected by the atmosphere and our protective magnetic barrier, the magnetosphere. Who was dealing with the problem? Air Force, Department of Defense with military around the world, the satellite industry, making sure their satellites were not impacted, astronauts on the space station. So NASA was being well involved with these activities. So a lot of things were still going on, just nothing that would affect our daily life, right? There were other entities and technologies and users that relied and found that information critical to know during this whole event that started on Friday. And we're going back to the moon. As I'm going to show you later, it's not a great time to go to the moon when it comes to the threat or potential for the more severe types of these events, these solar radiation storms. The pictures you see on the middle, these blue images, that's from one of our satellites in space. And you can see how it suddenly looks like a blizzard hit it. because it's looking at stars in the background as it looks at the sun. That's from a solar energetic particle event, a radiation storm. That's what can happen to satellites out there. They start to get bombarded with these particles. And if they hit them just right on the electronic sensors and chips in the satellite, it can cause an erroneous command to happen that can make the satellite inoperable. Very unlikely, but it does happen. It's happened in the past. It'll happen again. Coronal mass ejections. These are the big daddy. These are the big one. So this, the coronagraph you saw earlier with blue, you're seeing the same thing here, but in a different color, a little closer to the sun. So what you're seeing is the white circle is the diameter of the sun. The black circle is the artificial eclipse. So think of it as an engorged moon covering up the sun. And we're looking at the outer corona of the sun this way from in space, 1 million miles from Earth. So 92 million miles from the sun. When a CME happens, it's an eruption of solar material called plasma that sends out into space, and they expand quite rapidly. Remember, 109 Earths fit across the center of the sun. So in the image on the top left, you can see how big and quickly that starts to expand. It reached that distance you're seeing in that picture in just a matter of 3 hours when it first emerged beyond that occulting disk, that black circle. The one on the bottom right is what's called a full halo, where it shows it's circling the entire sun. That's because it's like near center disk in the sun and it's going straight out, meaning probably straight out towards Earth. Now, even when we see these on the side of the sun or near the limb of the sun, we still have to look at every single CME very closely because they expand so much. And 93 million miles is a lot of expansion time. So they can still clip Earth, even these ones that look like they're near the limb. But the full halos most certainly can be an issue. Now, every time we see a full halo, it doesn't mean it's directed towards Earth. It could be on the other side of the sun going the other direction. So we have to use our other tools, such as Air Force observations on their optical telescope networks and on their radio telescope networks to give us clues as to which direction this is going. Because we don't have a radar in space like we do on Earth when we can tell which direction a wind is going and see all sorts of signatures that tell us severe storms in progress. Yeah, we don't have that capability in space, so we just have to use other information. Now, these are the things that can result in the G scale, the geomagnetic storms that happen here at Earth. So this slide looks very complicated, but I'm going to make it very simple for you by basically ignoring the picture on the right, but just look at the picture in the middle. Planet Earth with the red lines. The red lines is Earth's magnetosphere. So our magnetic field comes out the bottom of Earth and then goes into the top. So it's orientated up, northward. So think of it as a thumbs up. Now, coronal mass ejections aren't only carrying solar material, energized particles, and plasma. They have an embedded, very strong local magnetic field that's being stretched out into space from the sun. So when that magnetic field comes along, if it's pointed the same direction as Earth's, we'll get an initial punch on our magnet field, currents will spin up, we'll get a geomagnetic storm perhaps, but it may not really intensify. But when it turns south, now think of it like you're connecting a positive and a negative magnet. Boom, we connect. And that's when the activity can really spin up. That's when we start to get to these upper levels on the G scale for geomagnetic storms. That's when the power grid can feel some issues, especially once we start getting to G3 or higher. That's when things you see on the bottom begin to happen as far as other effects and impacts with regards to a geomagnetic storm. We've already had some big events in 2023. Now we're just starting the new year. So we've had plenty of G1s. We've even had a couple of times where we've hit G4 already. They weren't significantly impactful, but they were notable. I guarantee you the North American power grid was taking actions in some spots to make sure there were no issues. Not that they were going to have any, but they were spinning up procedures to mitigate any potential problems, whether it's sending out personnel, a technician out to a transformer and listening, or looking for overheating on the transformer. Some were doing that. Some were spinning up extra lines to monitor to make sure they were seeing how many amps were showing up on the line above normal. So they do take measures. They do spend money, invest in things. Fortunately, nothing happened with this. Some actually saw more amperage than they've ever seen in their lives in the 30 years they've been working there with some of these storms, but it was not impactful. The power grid was never at a threat to collapse. because we were kind of only on the low end of a G4, not on the high end for a prolonged period of time. February 27th, even March and April around here in the mainland, some of the best aurora sightings seen by people had happened with regards to these storms. I think the northern lights were seen in Oklahoma, which surprised me. Northern California, some places that normally don't get to see them actually saw them with some of these activities this last year. Okay, this side is very busy, right? We're not supposed to do this when we're presenting, but I did it on purpose because it's a very informative slide and I want you to be able to reference it if you ever have questions in the future, because I think I answer most of them on this slide about geomagnetic storms. But I kept it busy because I wanted to give you a sense of how busy we can get in the forecast office when it comes to just only a geomagnetic storm. Let's pretend we're not dealing with the radiation storm or solar flares that are kicking in into the NOAA scale levels. Just a geomagnetic storm, just one geomagnetic storm. This is the actions that we're doing. So the things that I'll draw your attention to is the left part of the plot. You'll see these numbers going up 0 through 9. That is actually how we measure geomagnetic activity. We take observations around the surface of the planet, these things called magnetometers. They're like a seismometer, except they're measuring magnetic field changes. And it's consolidated. We get a planetary index. So 0 through 2 means quiet conditions, nothing's going on. KP of 3 we call unsettled. There's a little bit going on, but nothing notable. KP of 4, that's our first warning. Believe it or not, that's active levels. KP of 5, that's G1. So now we're issuing our warning and we're making 2 phone calls to transmission operations centers in the northern part of our country. They already want to know. KP of 6, that's a G2. We're talking to air traffic control out on the West Coast that does the Pacific region area. And we're calling NASA for the benefit of the astronauts on the space station because there's changes in space that can happen, especially when there's a radiation storm going on, that can make the astronauts a little more exposed to an issue. So they may want to scrub a spacewalk, for instance. KP of 7, that's a G3. We're doing everything I just said and a few more calls, and we're making the NERC hotline call. So essentially, we're calling the entire power grid of North America and letting them know in one phone call what's going on. Remember, not that they're anticipating any problems, but now they really want to know and pay attention because it could escalate quickly and we could hit higher levels than that. We get the KP of 8, a G4. We're talking to FEMA National in DC, and we're talking to FEMA Backup in Denver, as well as a Mobility Operations Center down in Denver, and everything else below. We get to a true G5. We're probably informing the National Security Council at this point, at the White House, is going to be informed. So that's why that slide is busy, give you a sense of that. The other thing I want to point out is when it comes to measuring geomagnetic activity, that 0 through 9 scale is divided into thirds. So each number, you have a low end, a mid number, and a high number. So you could have a KP of 5M, a KP of 5Z, KP of 5P. That's still all G1. That's what I'm describing on the bottom. The reason that's important is a true G5 is not until we get to KP of 9Z. So G4 includes all the way up through KP of 9M. So it's not a direct conversion all the way across. That's why it takes so much to actually get to a true G5. So when I said we were on the low end of a G4, that's what I mean. We were like at KP of 8M or KP of 8Z. We never really got to a plus on that end. This is the NERC. This is all the reliability coordinators, like 18 or 19 of them across North America. Even a little portion of Mexico is included on that, by the way, in the Baja. This is everybody that gets on that phone call when we spin up that NERC hotline call. So very important phone call. This has been dictated down from the federal government via the Energy Commission, the FERC, on through the NERC, and then on down to us to make sure this is done. And we have a close working relationship with the NERC to make sure we're giving the best service we can when it comes to this activity, and that it's a true partnership. They give us information as well about any about what some of their lines were reading to our scientists here. This is the geoelectric field model. I bring this up, not that you need to know it, but to give you an idea of what this means for the power companies. So we put out these warnings and watches and alerts for geomagnetic storms based off that KP scale. This is what they really want to know. They want to know what that means as far as how many volts per kilometer is showing up on their high voltage transmission lines, because that's what's really going to give them the problem. This is normally measured in millivolts, thousands of a volt. When we get to just 1 volt per kilometer, that's noteworthy for the power companies. We get to 10 volts per kilometer, that's a problem. They're dealing with some issues. We get to 100 volts per kilometer, which is kind of that 100-year storm or more scenario, that's impactful. There's going to be problems there. And somewhere around the world, at the very least, somebody's going to be having some major issues. So this is why this model is out there, to help power companies get a better sense of what they might be seeing. Just kind of a summary of what we put out with regards to alerts, watches, and warnings. Geomagnetic storm is the only thing we could put watches, warnings, and alerts out for, because we kind of have a 1 to 3 day notice for these events. They're the slowest moving of the whole batch of events. Warnings, we put out for radiation storms, but they may not have a very big notice. It may just be minutes before it hits, because they can travel almost the speed of light. We see a flare and it's in the right spot for a radiation storm, it can be here in 15 to 20 minutes. And then we alert for every single level. And flares, we don't even try to alert. We don't try to warn on, because we have no way of knowing that one is imminent. Instead, we send the alert out when we hit it, but we forecast the probability of every single thing you see on this slide here. So they're always in our 3-day forecast, all of this. Here's where we're at in solar cycle 25 so far. The left side of the purple box kind of shows you where we're at right now in 2024. The light red pinkish shade is the original forecast before the solar cycle started, so some years ago. We've been much busier than anticipated. This forecast had to get adjusted quite notably. So now the new Solar Max prediction is more active than before, and probably going to hit a peak sometime later this year. But that doesn't mean the activity shuts off. Activity is going to continue to be a threat at the severe and extreme levels all the way through 2025 and even into 2026. When are we going to the moon? Later in 2025. When are we having our first woman walk on the surface of the moon? 2026. So we are going to be very closely involved with NASA. We'll probably have one of our forecasters deployed to Houston to work with NASA directly to help support the astronauts and their health. Some notable space weather events. Notice the one in 1859. That's the big one. You may hear the word Carrington event. That's kind of that 1 in 100, 200 year type storm. This thing caused the aurora to be seen in Hawaii. Imagine that today. That's the concern. That's what puts up those billions of dollars of estimates of potential impact to commerce. Because if that kind of storm happens again today, our technology that we have in our year that we're living in is going to be impacted. It's just a matter of how badly and how much. Other more recent events that never reached that scale, but they were impactful. 1989 caused 2/3 of Quebec, Canada to lose power in the winter, in March, freezing temperatures due to a space weather storm. Halloween of 2003, damage to the grid in South Africa and Sweden and other places. Satellite loss. Notice that. There was a satellite that was damaged out there and unusable. Soldiers have been killed, deployed on duty. Why? Because of communication issues. They didn't get words that they needed, and there was space weather going on that caused the comm issues, and 3 soldiers were killed. So, yes, impactful space weather. More recently, just in 2023, we had a massive CME rip off the sun. Fortunately, it was directed the other direction. This was one away from Earth. The model on the bottom kind of shows you that on the right. Earth is to the right. The CME was going to the left. This thing was very strong. It was almost at the Carrington event level speeds. Now, what that means when it arrived here at Earth, if it had, we don't know. But once again, we're not out of this. This is the way it's going to be for the next several years, is these types of things. Just last night, we had a big CME rip off the backside of the sun again as well. Emergency management is hugely involved now, thanks to government regulations and guidance and training. FEMA is big into this. We're doing a major exercise, paper exercise with FEMA Region 8, which covers Colorado and a bunch of the Western United States, just about a space weather event. Get rid of that. Hide. And a lot of states, cities, counties, states, I've been talking to a lot about space weather, and a lot of them are putting in their hazard risk mitigation plans. How do you stay informed? You visit our webpage. That's where you can get most of the information you're going to need, including dashboards singled out for the EM community and some models of note that you might want to know about for GPS accuracies and such things. How do you get informed? You can subscribe to specific products through our product subscription service on our webpage. That's shown on the left. And if you're involved with emergency management or other government officials, you can subscribe to alerts to your personal cell phone via INWS on the right there. So if you have more interest in getting certain types of space weather alerts and you see the asterisk stuff in the bottom, you can sign up for INWS. Here's a flare from, when did I call this up? Oh, the December 31st event, the one that caused the radio burst. This was this flare. You can see the sunspot group there on the right, and then you can see the flare kicking right there as that event. That's what caused all the radio disruption right there. This associated radio burst with that. What does that look like? When it came to the coronal mass ejection that was associated with that compared to the size of the sun, there you go. You can see how that's moving out into space. That clipped Earth. It gave us some storming here, but nothing significant. It was not a direct hit. But these are the things that us forecasters are analyzing for continually in there. So you get a sense of how big the coronal mass ejection is, how quickly it expands compared to the tiny size of the flare that was associated with that. And with that, I'll wrap it up here. Thanks very much for tuning in. There's additional training resources out there. The Colonel shared one of the links, and that's up here on the top as well. Some good FEMA training out there on space weather. There's a good document out there on space weather that Homeland Security has produced regarding the impact and what space weather events could be. And then, of course, we have our own resources on our SWPC webpage for you as well. So with that, I think I am done and happy to entertain between myself and Colonel Bloom any questions that may be out there.
Okay, I think we have a question from Tori asking what kinds of models do you use to forecast any space weather events? And are they models of the Earth's atmosphere, or do you also simulate the behavior of the sun?
Yeah, we're not using anything here that shows the behavior of the sun. The closest thing we have to that is the model that we rely upon that shows us, gives us an idea of whether a CME is going to impact Earth or not. And that's called the WSA NLIL model. You'll see those on our webpage. They come out once a day. And if we're forecasting a CME, we'll put that particular model run and freeze it. So if you click on the WSA NLIL model on our webpage through the products part, you'll be able to see that CME run for yourself and see how it's moving towards Earth. Other models are used to give us a sense of the solar wind and the changes going on to help us forecast geomagnetic activity here at Earth. And we have that geoelectric field model. Unfortunately, we don't have anything, like I said, that gives us a sense of dynamic changes going on in the surface of the sun that could help with flare prediction. There are things being developed for that. MAG4 is one of them. So we do have things out there that are in development.
Okay, thank you very much. Another question for Monica Gowan. Aside from the power outage situation, what is the potential impact on internet infrastructure?
Internet, there was a lot of stuff out there recently about an internet apocalypse. I think I remember seeing this story. There's not a whole lot of, that's still kind of a science study going on, but nothing like that is anticipated. Where the internet could be affected, though, is from a geomagnetic storm that causes a power outage or a problem with the way the internet is sent through not fiber cables themselves necessarily, but through, I forget what they're called, the little stations that help escalate these signals across the water or coming up from the oceans if they're not directly going through satellite uses, which a lot of these are still done that way. That's where there could be a folding of the internet, but nothing in general is expected to affect the internet due to a space weather storm.
Thank you. Greg Winnison, how does CME impact Earth versus EMP?
Yeah, there's, I forget how this came out, but unfortunately, some government regulation or guidance that came down put GICs in with EMPs. And for those of you that don't know what those mean, EMP is electromagnetic pulse. That's from nuclear detonations and things. GIC is what we're concerned with. That's the geomagnetically induced current caused from geomagnetic storms. There's really no correlation right here, but somebody thought it was convenient to put them together. So it makes for a lot of confusion. EMPs are much stronger and much more impactful than a GIC would be because it would be very widespread from an EMP. The GICs themselves are really what we're focused on here, and it's unrelated to an EMP. And that's what I was showing you with the geoelectric field model.
Thank you. Paul Brislin asks, how much notice will we get of a major impactful event? And also, thanks for the great presentation.
Hey, you're welcome. Thank you for that. And my hope, okay, there's a good and a bad to this. You may have saw it on the one slide. We don't put watches out for G5. We do G1 through G4. That's it. We very rarely have put out a G4 watch. If you see us put out a G4 watch, we think something really good is coming. I mean, fast. It would probably be here within a day type thing. Now, so if you get a watch and you see something like that, a G3 watch, we usually kind of correlate with a CME that we think is more directed towards Earth than not directed towards Earth. So it's kind of, they're almost an expression of confidence sometimes. But here you go. To answer your question, a big impactful event, we could get the watch out in a day because it's moving fast. We're not going to get a watch out any faster than that. A warning would be going out probably as soon as we see it hit the satellite 1 million miles from Earth, because that would give us about 15 minutes or so, maybe a little less lead time. But we have to wait. We don't know until it hits the satellite, right? We can expect timing, but 93 million miles, there's a lot of variances in how fast something's going. So we get the warning out maybe in as fast as 15 minutes or so, and then the activity would be hitting here at Earth soon after, and we'd be starting to issue alerts immediately. So that's kind of your worst case series of events. Normally, the way things work, we can get a watch out 2 to 3 days in advance because things are moving slower, and they arrive, and we'll get a good 30 minutes or more of notification of a warning from any geomagnetic activity.
Thank you. George Atta asks, what kind of health impacts are possible, including short and long-term possible impacts?
Yeah, it's radiation sickness is the concern due to the exposure to these energetic particles in the form of protons coming from the sun. Now, all of us here, even if you're climbing Mount Everest, you're not going to be impacted by these events whatsoever, regardless of their severity level. It's really about how there's 2 ways we measure the energetic particles that cause radiation storms. One is by the number of them, and the other is by their energy level. So think of it like you're measuring the movement of a normal male, and then you're looking at the movement of Superman. So, they have the same stature, right? Superman's just got a lot more energy. He can go faster than a speeding bullet. That's kind of the way these energetic particles are that we're looking for. So when we get to these higher energy levels, even if it's a low number, that can be impactful to aviation that's flying near the polar regions and high altitudes. The radiation concern in particular is for pregnant women. So there's a lot of studies out there from the FAA and others that are involved in looking at that kind of thing. Astronauts in space, not nearly as protected as we are on the surface of our planet. And we start to get to those extreme levels of activity, especially when we get those higher energy levels bombarding, they can penetrate things and penetrate human tissue. So they would get radiation exposure and perhaps radiation sickness. We don't think that it's lethal, according to the experts. There was some thought that maybe the event that happened between the last 2 Apollo missions back in the 70s, there was a very severe to extreme event. And if astronauts had been in space, there was some talk that they thought maybe that could have been lethal. Now they're thinking maybe not. So there's still some doubt on that. And I guess we'll learn a lot more as we send brave astronauts back out into space here on how that can impact them. They do have measures to take, though, when these situations kick in. And I probably don't have time to tell you what those procedures are, but they have plans in place to deal with these storms because there's nowhere for them to go, right? They're stuck on a space station out in space somewhere near the moon or between us and the moon.
Thank you. Mary Sheridan's asking, I was reading about the discovery of a 3rd class of magnetism, ultramagnetism. Can this possibly be used to prevent a high electron event?
Interesting. I do not know anything about what was just brought up, so I can't answer that for you. But you did say something about electrons. I said there's other things we're forecasting for out there in space. Electron values is one of them because they can accumulate on satellites out there and cause their own types of issues when we have an enormous amount of electrons outside of normal that have filtered out into these layers of our Van Allen radiation belts and other such things where our satellites are sitting out there. Kind of, like I said, doesn't answer your question because I can't answer that. I don't know, but it just made me think of something else to bring up.
Thank you. Ashley Parks asks, do you have a time frame in which you have to get your alerts out when impacts start, like a KPI?
Yeah, as soon as we see the activity meet that level, and also keep in mind these are estimated values. We don't. This is a tool that we have in house that's called the real-time estimated KP tool, and that's our guide. That is what we're issuing our alert based off. So if the estimated figures from all the magnetometer deviations going on come in, and we're hitting KP of say 8M, that's an issuing alert. And that's I mean right away. We just kind of drop everything else and we have to issue that alert. So that's the kind of top priority. So it gets out right away.
Thank you. Do we have any concerns for the solar eclipse scheduled for April?
No concerns at all. The interesting thing would be that if we have let's say we end up hitting an R4 or an R5 type solar flare, anybody for those 4 minutes who's in the direct middle of totality, may not have an impact to HF radio, right? But it does heat up other parts of the atmosphere that are nearby, so there probably would still be a problem. But no, there's not going to be directly any space weather related issues. It doesn't block anything. It doesn't prevent anything from happening here at Earth. It would still continue. The biggest thing with the eclipse is it happens to be kind of in solar maximum. So some interesting things for astronomy buffs that are going to be in the path of the eclipse, or if you're traveling to be in the path of the eclipse, would be maybe in the corona, you might see a coronal mass ejection going on.
Lastly, do you see any areas of higher activity when we're talking about space weather on the Earth or around the Earth?
Yeah, exactly. The polar areas of our planet are the most susceptible to the radiation storms, the aurora, meaning the geomagnetic storms. It doesn't take much to spin things up there. The stronger and more extreme the activity gets, the more intense any issues that people are used to up there would notice. Like I didn't talk about it, when the aurora starts to get overhead, that causes its own HF communication issues. So the Air Force in particular is very keen on monitoring the extent of the auroral oval that's going on. As far as effects to the power grid, it does matter where you're located geographically and what the geology is underneath the surface, because that plays just get rid of that again. That plays a role. So the more resistive the rock, the more the GICs, those induced currents, are going to want to find the shortcuts. Those shortcuts are pipelines, railroad tracks, power lines, anything that can conduct electricity. So people near salt water also a little bit more prone, because things will find ways to travel a little more quickly as well. So the east coast of the United States and the upper Midwest, these are areas where things are much more favorable. And also that happens to be where Earth's magnetic field naturally dips down a little bit to allow activity to be even at a higher level further south than one would anticipate.
Thank you so much, Sean. I know that we have some closing comments by Kirsten Turner, who's our Assistant Executive Director here at the National Disaster Preparedness Training Center. Kristen, would you like to chime in?
Sure. Hi, everyone. I'm Kirsten Baumgart Turner, the Deputy Director for NDPTC, and I'm relatively new, so this is an incredible education. Sean, I don't think I've seen a better, more excellent presentation of what is very complicated material, so thank you for making this understandable for some of the less informed in this area. Particularly myself. I just want to thank also the work that you're doing. It's just amazing work at the NOAA Space Weather Prediction Center. Who knew, right, that we're in a solar radiation storm since Friday last week, and that satellites have been impacted by them, or that solar flares have affected air traffic controllers in the USA. That's news to me, so this is really helpful. Also, I had no idea that the aurora was ever visible in Hawaii. So, wow. This is particularly meaningful for NDPTC, and I think many of our staff who are participating in this webinar today are appreciative as well, because we're looking at the development of a satellite technology class that emphasizes both sensors and satellite communications. I'm sure we're going to be drawing on the tremendous resources that you folks have as we look into developing this. Our annual report is also out for everyone's information. I hope we'll put it, Karen or one of the staff could put a link in the chat here. And I just want to mention a couple highlights from the annual report. A lot of you may not be aware of what NDPTC does, and just completed my 3rd month here, and I'm still trying to digest the amazing work that our staff does with instructors nationally, as well as delivering to our US territories in the Pacific, and that we're the only national disaster preparedness center that focuses on natural hazards, mitigation, preparedness, response and recovery. And so we, as the FEMA certified center that is one of the 7 congressionally authorized centers, have in 2023 trained participants in every state and territory. I understand that this is a first for us, that we've not always gotten to every inch of the USA, but we've done that. We also have provided through those 5,162 participants that have successfully completed a course. And those are through 226 instructor-led deliveries and 2 asynchronous web-based deliveries. So that's pretty amazing work on the part of our staff, and I really thank them for their dedication. We also achieved 60,229 course completions as of the end of December from our beginnings in 2010. So we hope to continue increasing this, and as you're all aware, because NOAA puts out that information, that the highest number of disasters took place last year, and that those are increasing. So I really want to thank the work that you're doing at Sean, because this is an area that most people are just not aware of, and that we're just beginning to look into how we can support this through disaster preparedness and training. Finally, I just want to mention that we have several platforms, and I hope I've got to look here in the chat that you'll look at our website and look at the course deliveries, and know that our primary course delivery mechanism is through state and county and municipal agencies, but that we are also focused this year on delivering more to indigenous communities, focused more on delivering on the Justice 40 focus of the Biden administration, and also focused on community outreach and engagement. And so that is an important part of the work that we do, and we hope that you'll support us in that endeavor. Anything I left out from my staff that you think that we should add here, I welcome you to mention. Okay, and I want to also thank you, Karen, who I think does a great job of helping to MC this and to facilitate it and to put these events together. It's an honor to be able to share out the important work that NOAA is doing, one of our major partners. And so we really appreciate it, and we appreciate the work you're doing, Karen, to help get them delivering this information to the whole community.
Thank you, Kristen. Thank you for your help.
Yeah, and I just want to mention our executive director, Carl Kim, is online. He's not able to speak at this time, but his guidance and leadership is also through the partnership with the University of Hawaii, as many of you may be aware, and that he continues to do research, and that goes into the development of a lot of our courses. And he also delivers courses at the UH as one of the experts in climate resilience and transportation, not just in the US, but internationally. So you can always reach him through his leadership at NDPTC or directly at the University of Hawaii.
And also, I'd like to ask if Lieutenant Colonel Todd Bloom would also like to share any comments. I know that we had initially made contact with him for the presentation, in which Sean did an excellent job on.
I just, again, wanted to thank you all for reaching out. And again, thank you to Sean and Major Austin Gibbons, who helped kind of coordinate and put this together. Again, Sean's presentation was much more detailed and much better explained than I could have ever done. And I just, appreciate you, Sean, for highlighting our partnership together, working with Department of Defense and Department of Commerce. I think it's extremely valuable, and it's really awesome to see this just continuing to grow. So thank you all. And please, use the resources that Sean provided there for additional, education and just reference. I use it all the time. It's very helpful.
Thank you. Mahalo.
Yeah. Thank you all for the kind comments. It is my pleasure to join you today. Thanks for all you do as well. Thank you.
Thank you, Sean.
And mahalo to everyone for joining us. I think we had 77 on this webinar, so you can see the interest, and also I'm sure that there will be continued interest in our webinars. So tune in for
Yeah, we actually had close to 90 attendees.
Close to 90,
Us
great.
Attracting the
Thank you.
the registrant list.
Great.
Thank you so much, everyone.
Have a great rest of your day. Aloha.
Aloha.